Well, thanks everybody for taking the time today. We're very excited to go over our new product offering for the electrical subvertical on cable glands. Today's kind of training will go an overview as to what are cable glands, as well as kind of our entire product portfolio that we're offering. So going into it now, just as I mentioned, today is going to be about cable glands. But they're also known as cable connectors, or core grips, or fittings, and really they're there to fulfill four main functions. It really comes into, in terms of an entrance for the cable conduit tube into the housing and enclosure. The cable gland will then provide also strain relief for the cable, and then provide protection to ensure that the enclosure remains the same IP rating or whatever rating it has, and protect the inside of the enclosure from water, dirt, and dust. And this also allows the customer to easily assemble and disassemble cables and enclosures by working through the cable glands. So in terms of a kind of quick definition of the cable glands that we're going to be offering, so primarily made out of four different type of materials, from metallic and non-metallic materials, and they all depend on which application that are going to be used in. So your more common cable glands are going to be made out of plastic and brass. And then for certain hygienic applications, you might go into some stainless steel applications. So we'll go over some of the different offerings and what products we have in their materials and the applications that they have. Just broad overview, what we see here in the market are the two primary products being the plastic cable glands made out of polymer, which are more used for standard type of industrial applications, and then the metal cable glands in terms of some of the harsh and hazardous type of applications. And now we'll just kind of go into a quick video if you're not familiar with what cable glands and how they work, just to give you an idea how they actually connect, how they're being used in most applications. So kind of going back to the basic construction of most of these cable glands that you'll see here today, they're going to be made out of two parts, or two components that we will sell. So first is the cable gland itself, which is made up out of the cap, the seal, the body, and then the O-ring. And then we will sell the O-ring separately, as well as the lock nuts separately. And some of them are higher volume parts, or the ones that we are keeping in stock as well. But for the main part, most cable glands are going to be made of these different sections, and be sold then with the cable gland, which will be the body, the seal, and the cap, and then the seal and the lock nut separately. And we see this as a starting point. So we're looking at right now our offering being more focused toward industrial type of applications. So we have our industrial glands, we have some ventilation and drain systems, some of the hygienic, as well as the accessories that go along with it as a one-stop shop. But from a future standpoint as well, areas that we're going to be looking into expanding are more into some of the harsh and hazardous applications with explosion-proof type of glands, as well as more on the core grip and strain relief products, and as well as going more on the conduit side as well with some flexible conduit offering.
The next few slides, we're going to walk through some of the questions you should ask when it comes to product selection. These are in no specific order. They're in a logical order as I present them here, but just know that sometimes maybe one of the questions at the end will help you get to a specific product faster, and I'll explain an example when we get there. You might want to start with identifying the environment that the cable gland is going to be used in. The first question might be a little bit tricky. Is it indoors or outdoors? All of our cable glands can be used indoors or outdoors. As JY pointed out, we do intend to expand into other cable gland areas like hazardous or explosive environments, but if your customer has that type of environment, we don't have a product for that yet. Next, you might want to consider if it's food and beverage application, maybe biopharma, any type of application where hygiene is a really top priority. They're going to be decontaminating the space. Then you might be looking at our hygienic cable glands. Temperature is a relevant data point to understand. You'll see in our product literature that the cable glands, whether it's the plastic or the metal glands, have different operating temperature limits. IP ratings are really going to relate to whether it's a damp or dusty environment. For simplicity for you, most of our cable glands have the same IP ratings, so it's not necessarily going to be a huge differentiator in our product line. They all have pretty high IP ratings, and I'll touch on those in more detail as we go in detail on the products. And then another consideration for the environment would be whether there's any corrosive materials nearby. While the plastic cable glands do have some chemical resistance, when you get into those harsher environments, you might be considering brass or stainless cable glands. Next is to define the cable type. So is the customer running cable or conduit into the control panel? What's the diameter of the cable? That's going to prescribe the gland size, and what type of cable is being run. You'll see in our product offering that we have EMC shielded cable glands. We have cable glands for RJ45 cables, and then just regular cable glands for all types of braided and solid strand cable. Important fact is that the cable gland size is going to be equal to the size of your cable bundle diameter. So if your bundle is 50 millimeters, that means you would need a 50 millimeter cable gland. So a little helpful sizing information. Third, you want to define your thread types. So to provide flexibility in selection and accommodating different customer requirements, we offer 3 different thread types. Almost all of our glands are offered in all 3 thread types: metric, PG, and NPT. Generally, we've listed here the locations globally these thread types are used, but we might find that many US customers, for example, prefer metric sizes. So there's no right or wrong answer to this question. Customers can mix and match if they choose so. I don't suppose many of them will. The point here is that we wanted to include options. The next is to determine the cable gland material type. So I mentioned that we have plastic, brass, and stainless steel cable glands. And it's easier to just think of the nylon or plastic cable glands being suitable for most industrial environments. When you start stepping into harsher environments or more highly sensitive environments, brass cable glands will provide additional durability, corrosion resistance, and then of course the highest hygienic cable glands, if you will, would be the stainless steel from a material standpoint, each one providing kind of an increase in performance. Most cable glands are going to be threaded, so threaded with or without a nut, and we will be stocking the cable glands threaded with nut. The other type of mounting we have is a snap-in type cable gland. This is pretty cool. We hope that we see some demand because it's kind of a unique solution. It's going to save time in installation, where of course you don't have to put a lock nut on the back side of the cable gland. So installation is faster. It also can be cheaper. So I spot checked a few of our different sizes, and in some cases, the plastic cable glands, the snap-in is actually a cheaper product as well. Plus, the customer realizes some time savings. Finally, and this is where you might ask one of these questions, and as your first question, and it'll get you to the product the customer needs faster. For example, if the customer needs to handle shielded cable here, as an example, that's going to really narrow the scope of products to just our EMC cable glands. So there are some special applications, special functional areas where it's going to drive you to a specific product a lot faster than kind of going through the previous steps, just because they have such specific uses. I want to pause real quick and just define a couple of things that I don't want to take for granted. Some of you may be familiar with the different thread types and IP ratings, but in case you're not, we have this convenient vocabulary sheet for you. NPT stands for National Pipe Thread. It's pretty common here in the US, I think probably North America as a whole. It's a tapered type thread commonly used on steel, iron, brass pipe. The thread pitch and the fact that it's tapered don't really make a functional difference here. It's just we wanted to describe the threads for you guys so you understood the difference. PG stands for Panzergewinde. It's a German thread type, and it's quite a bit shallower than metric threads. So if you can see the thread depth here compared to the thread depth on a metric thread, it is shallower and it's got a wider pitch angle. So it's a bit coarser but shallower. And then of course, metric thread. We included an example here of the taxonomy just to help you guys understand when you're reading a description of one of our glands, what these numbers mean. In this case, the M20 is just defining the metric thread type, 20 millimeters with a 1.5 millimeter thread pitch. IP ratings, I'm sure they're not new to you all, but there's a link in the presentation here when we share this with you if you want to explore what the different IP ratings mean. I learned a lot just referencing this link, so I wanted to include it for you in case you wanted to do a little more exploring and understand exactly what the difference is between, for example, IP66 and IP68. So just a helpful resource here for you. Next, we want to highlight some of the value propositions. As JY pointed out earlier, this product category is very fragmented, but also wanted to highlight some of the things here that can build your confidence and give you value proposition. For reliability and harsh environments, I mentioned a lot of our cable glands have the same IP ratings. So all of our brass and polyamide plastic cable glands will have an IP66 and IP68 rating. So there's a little bit of versatility there, but really great IP ratings. We also have a line of EMC cable glands for shielded cable. We actually have two different types to offer, kind of a basic model and enhanced or advanced model that provides a high degree of vibration resistance to prevent damage to those shielded cables. And we also have a range of hygienic cable glands. So this would be our stainless steel, highly sealed cable glands that actually achieve up to IP69 or 69K, which is high temperature steam cleaning. From a flexibility standpoint, I mentioned that we have the three different thread types, so hopefully accommodating what our customers need. We might, in the future, when we start getting into hazardous cable glands, we may introduce another thread type for gas pipe threads. But for now, we believe we have really the top three covered in the metric, PG, and NPT. We have that snap-in gland that I mentioned, and we offer our glands with and without lock nuts. The obvious convenience with including the lock nut is the customer doesn't have to order multiple components, and installation is relatively simple since they have everything they need to install the cable glands. We have a ton of different applications that our cable glands can accommodate. I'll touch on each one in detail later on in the presentation. You can now design around the portfolio of ENTRELEC cable glands. The offering we have should accommodate a wide range of industries and use applications. And then finally, we have different material and color options. I already mentioned that we have the plastic, brass, and stainless steel materials, but we also have three colors in most of our plastic, all of our plastic cable glands and most of our plastic components will be available in three colors: light gray, gray, and black. And then last, I wanted to highlight the fact here that not only do we have a lot of different products, a lot of different configurations, a wide range, but really a nice trade-up story for customers as well, whether it's based on the material for the end-use application, harsh environments. Even within harsh environments, we have different degrees of performance. So I mentioned we have two types of EMC cable glands, for example. And then from a trade-up perspective, we have economical solutions, so the plastic cable glands or cable plates. We have a line of cable plates that is in this portfolio, but then we also have the more durable brass and higher-end stainless steel cable glands. I'm going to start getting a little more specific into the individual collections. From a high-level perspective, we have 5 main categories of cable glands. So we have threaded cable glands, both with and without lock nut, available in brass and polyamide. We have snap-in cable glands, which are available in polyamide and brass. RJ45 cable glands, available in polyamide and brass, and then EMC cable glands. 3 different types: EMC2, EMC4, and railway. I'll explain the differences in those in a little bit. And then hygienic cable glands as well, that are made of type 303 stainless steel. So these are the 5 main categories. And then we have a full range of product accessories. So everything from ventilation plugs to drain plugs, round plugs, those cable entry plates that I mentioned, lock nuts, gaskets, and dome plugs, which I will make sure to give you guys the reason for each one of these existence in just a little bit. We'll explore each one in detail. All right, for simplicity, the next several slides are grouped by material, since there are a lot of similarities across the different ranges. First, we're going to look at the plastic range with and without lock nut, as well as the RJ45 cable glands. You'll see one of the commonalities across almost the entire range is that we do achieve the IP68, IP66, and then the NEMA or UL type 1 and 4X, 4X being interior and exterior enclosure rated. The material itself is polyamide 6, essentially nylon. All of these are available in 3 thread types. And so I want to point out here that you do have a few more sizes available: metric, NPT, and PG sizes. A few more sizes available in the special order without lock nut. The ones that we're stocking, for example, we have 5 metric sizes versus 9 total available. We'll be stocking 5 with the lock nut. So that's one difference. Performance-wise, it's the same exact product. We've just chosen to stock a limited selection of cable glands with the lock nut. The RJ45 cable glands also achieve the same IP ratings, but we want to take a second and point out a unique feature of the RJ45 glands. So this cable gland will allow the RJ45 cable with a connector to pass through the gland, and in order to create that seal, the seal will actually snap onto the cable. So if the customer's using pre-configured RJ45 cables as jumpers, they won't have to cut them essentially to get them through the cable gland. They will fit through the gland with the connector in place. So kind of a convenient feature of those cable glands. Continuing on with the plastic range, so did want to touch on the snap-in glands a little bit more. These still achieve the same IP68, IP66, and types 1 and 4X ratings. So they're nice and tight, very sealed up. I already talked about the fact that they're faster to install. We have a slide coming up right after this one that just kind of shows an exploded view of how it works, how it's installed, and then disassembled. We do have a collection of ventilation plugs. So these can be used certainly in electrical panels, but even some of the smaller sizes and types might have other applications in lighting devices, non-electrical panel type applications. And it's really cool. We even have, I think, 2 parts. You see here IP69K for D type. So we have at least two parts that will withstand high temperature, high pressure steam cleaning, which is pretty cool. So a nice little range of ventilation plugs available again in all three colors. And we also have a range of drain plugs available in the same light gray, gray, black colors. IP ratings are a little bit different for those since they are drains, but they will allow moisture, any collected moisture to drain from the panel or the enclosure. Here's an exploded view of how those snap-in glands work. So there is a removal tool. It doesn't come with the gland, but it can be ordered separately. The gland has ears that snap in, so it's pushed into the enclosure hole. The ears snap in place, and then there's a secondary nut that's just tightened down to create that seal and lock it into place. Removal is just the reverse. You would loosen up the secondary nut, use the removal tool to compress the ears of the gland, you can see here, and it's simply removed from the enclosure. So there's no loose lock nut or seal or O-ring or anything to get lost, or for a customer to forget to order. It's just one piece that snaps in and locks down. I think it could really speed up their assembly, and as I mentioned before, it's not always going to be more expensive. It could actually be cheaper to buy the snap-in glands. Our drain plugs will accommodate a range of different enclosure wall thicknesses, but may or may not need a nut. So for enclosures up to 3.5 millimeters, you can use our special lock nut. What's special about it is it has a groove in it to, of course, allow the moisture to reach the drain hole in the drain assembly. And then for enclosures 3 millimeters or thicker, you can omit the lock nut. Of course, it needs a threaded hole to screw into, but it will allow water to drain in with or without lock nuts, depending on the enclosure thickness. Now I'm going to go through a series of similar slides for our brass cable gland range. You'll see a lot of, I know this information is going to feel redundant, but the reason for the redundancy is just to make sure that there's a slide, a place for you guys to go to see the information for each one of the products. So with our brass cable glands, we have the same offering of threaded without lock nut, threaded with lock nut, and RJ45 glands. And as I mentioned earlier with the PG glands, the non-stocked without lock nut does have a few more sizes available. So it's safe to assume that we've stocked the common sizes with lock nuts, and then a few other sizes are available on special order without lock nuts. You can see the IP ratings are the same as they were for the polyamide range. Our brass is nickel plated. Of course, it adds a little bit more corrosion resistance. The RJ45 cable glands in brass work exactly the same way as they do in the polyamide range. It's got that hole in the cable gland that'll allow the connector to pass through, but the snap-on seal that you can see here in the picture. The snap-in gland is also available in brass, with one caveat. The push-in portion with the ears that locks in place, that's still polyamide. The rest of the cable gland, everything outside the enclosure, is going to be nickel-plated brass. So again, a little bit more heavier duty, still works for those harsh environments. You know, a great option if customers like the snap-in, but they want to step up a little in corrosion resistance. We also offer two types of EMC cable glands. So I'm going to spend the next couple of slides talking about the differences, but think about it this way. EMC2 is going to be just your basic performance EMC cable gland for shielded cable. EMC4 is going to be your high performance EMC cable gland. It provides a little bit more protection during installation, and it also provides a lot higher vibration resistance that we'll see in just a second. I do want to highlight the IP ratings are the same, even across our EMC range, the 68, 66, types 1 and 4. So this animation just shows how the spring contacts in the EMC glands make contact with the shielding and the cable. As that cap nut is tightened, the springs are compressed against the sides of the cable. And then this helps illustrate the difference between the EMC2 and the EMC. Spring contacts are a little bit smaller and they have a different positioning than on the EMC4, which prevents, in the EMC4, prevents that vibration from potentially damaging the shielding on the cable. And another feature of the EMC4 is because of the design of the springs, when the cable's inserted, it won't cause any damage to the cable shielding. And if the cable needs to be removed or reinserted or repositioned before the cap nut is tightened, that can be done without damaging or risking damage of the shielding. The EMC2 will still allow insertion of the shielded cable without damage, but it's not recommended that you really move it a lot or reposition it because those spring contacts could cause damage with the shielding. Continuing along in the spirit of our EMC4, I want to talk a little about our railway cable glands. So these are EMC4 cable glands that carry that are compliant with EN rail requirements. But if you need rail compliant, specific to this EN 45545 requirement, we do have 6 metric sized cable glands that comply with that standard. All right, now we're gonna get into some of the accessories that we have. First, the different plugs that we have. So these are just hole closure plugs. We have two materials of round plugs, the polyamide and brass. These are for closing up holes in the enclosure. We also have dome plugs. that are made for closing up the hole in a cable gland. So let's say you have a cable gland installed in an enclosure and you want to remove the cable but leave the gland in place. You can plug that hole with one of the polyamide dome plugs, and that will provide the same IP rating as whatever that cable gland provides. So that's why we don't have an IP rating listed here. The round plugs would be used when you don't have a cable gland in place at all. So let's say you remove the wire and the cable gland and need to plug the hole. You can use one of our polyamide or brass round plugs. These are, this is where we start to depart from having the 3 thread types. So you can see that for the plugs, the round plugs here, we do have metric and PG, but we do not have an NPT thread type. Our hygienic range of stainless steel cable glands is pretty cool. It's pretty specialized. Definitely some interesting products here. We have hygienic cable glands that are just threaded. This is kind of the standard hygienic cable gland. We also have EMC hygienic cable glands, and then hygienic conduit fittings for passing conduit through into an enclosure. One of the things I want to point out here is that we do only have 2 thread types across our hygienic range. So we're using metric and NPT threads here. I also want to point out that the IP ratings are a bit different, improved, if you will, for our hygienic range. So we still meet the IP68 and 66, but we also meet IP69 or IP69K, if any of you run into that. For practical purposes, they're one and the same, as well as several different NEMA type ratings. These will, they're highly cleanable, highly corrosion resistant, obviously with the type 303 stainless steel, and they will, with that IP69K rating, they will resist high temperature steam cleaning. So great solution for food and beverage, biomed, pharmaceutical, any place where decontamination is a necessity around these. The next couple of slides just show you how these hygienic cable glands work. So these, I think it was pretty easy to see how the regular standard threaded cable glands worked. These require some special tools because one of the features is that there's a totally smooth finish, no exposed threads, nowhere for debris or bad actors or bugs to really find a home and occupy. So here's a quick video showing how it works. An Allen wrench is inserted through the cable gland and connects with a special nut that goes inside the cable gland. And this provides a means to thread the cable gland into place or into a nut, into a lock nut. The tools are then removed. As the cable gland's locked into place, the cables pass through. And then a wrench on the outside is used to compress the strain relief inside the assembly and create the final seal. So kind of neat how the fastening is concealed there. And this is the conduit fitting. So it's a similar process, but it shows you here the seal tight type hygienic conduit. If you guys have ever heard of seal tight, so our hygienic conduit fittings are compatible with seal tight conduit. The wire passes through the gland, as you can see, but this animation here shows the assembly. The conduit fittings do have a special wrench that can be used for installation, or the same Allen wrench technique can be used. So a couple different ways they can be installed into the enclosure. collar goes over the conduit itself. There's a bushing that goes into place, and then the final cap nut is tightened down to create that final seal, as well as the strain relief inside the assembly. So a pretty slick way of keeping things tight and clean. Continuing on with our accessories, as JY mentioned earlier, we do sell washers and gaskets separately. I haven't talked much about washers because they're not required. You saw in a few of the illustrations that the cable glands themselves have an O-ring to create a seal. If the enclosure has rough surfaces, or the customer just wants additional peace of mind, or just can't get a good seal with the O-ring, they can use our sealing washers that are available in 2 different materials, chloroprene or NBR rubber. Chloroprene essentially is neoprene. We do have a lot of different sizes to accommodate our full range of glands, metric, NPT, and PG. And we also have lock nuts available in the polyamide or brass materials as well. So you will find a lock nut for every cable gland we have, and material, with the exception being the stainless steel hygienic cable glands. We're going to take a few minutes and talk about our cable entry plates. So, you know, these go hand in hand with cable glands. Maybe the customer doesn't have the space, time, or budget to use traditional cable glands. So we do have this line of entry plates in a bunch of different sizes and a bunch of different configurations. So we have 4 entry plates, 7 entry plates, and 10 entry plates in this series, the BPA series. This is the higher performance. I'm going to show you. We do have another range called BRM, but I'll go through the BPA first. This is a higher, more premium cable entry plate because of its multiple components, and it also creates higher strain relief. I highlighted here on the slide that it accommodates cables with and without connectors. So that might be an important selling feature of the BPA cable entry plate versus the BRM cable entry plate. Once the multiple components are assembled and tightened down, like I said, it does create that strain relief for the cable. It does have multiple IP ratings. And then the BRM is more of an entry-level cable entry plate. This one does not accommodate wires with connectors in place. So the wire has to pass through before having a connector applied. Available in just these six configurations that you see here. It does not provide strain relief. And it doesn't provide a high quality seal. It's basically going to keep dust and a little bit of moisture out. You can see here it has a lower IP rating, and that's because it just has a very flexible grommet here that's meant to seal around the cable as it's passed through, versus the BPA cable plates, where when this main frame is tightened down, it compresses these seals into the frame and creates that really tight seal and strain relief. So hopefully I explained the differences between the BRM and the BPA cable plates for you.
In terms of some of the marketing tools that you will have available to you is obviously the brochure. We've now loaded most of the information on T.com as well. So there's 3D drawings. All the data is complete. The compatible parts are all listed. So, TE.com will be a great source of resource. We'll have a couple of the videos as well that you saw in the presentation here available to you, as well as this presentation as well.